Hello, Algebra students. This video is going to be on domain and range. This is part one of this topic. We're going to spend 2 lessons talking about domain and range. And notice the announcement when we do part 2 tomorrow. That is the last lesson in this unit. The warm-up is on the screen now. I encourage you to pause the video and try to answer those 2 questions because that is going to be the starting point for this lesson. Come back to this video when you have the answers. I'm going to go ahead and make the warm-up larger for our discussion. So the warm-up story was about the total number of times a dog has barked is a function of the time in seconds after the owner tied its leash to a post and left. I want to point out the phrase that we've been talking a lot about is a function of. Remember, when you see that phrase, it means whatever comes before the phrase. So in this case, the total number of times a dog has barked. Whatever comes before is always your output, and whatever comes after that phrase, the time in seconds, that would be your input. That's going to be important for this warm-up because the questions are about the input and output. So for the first question, you were answering, could each value be an input of the function? The input we said is the time. So we're asking ourselves, are these reasonable amounts of time in the story? So for example, since our input is in seconds, could you talk about 15 seconds? Absolutely. Could you talk about 84 and a half seconds? I've had some people question if time can be a fraction like that, but it can. You can have half a second, and you can also have 84 and a half seconds. For this last one, 300 seconds. 300 seconds does exist, but we are told that the owner returns less than 3 minutes after he left. And since our input is in seconds, it's important to know that 3 minutes equals 180 seconds. So in this situation, 300 seconds, while yes, that is a thing, we could not have that be an input because in the story, our time ends at 180 seconds. The second part of your warm-up was about the output of the function. Remember, we said the output here is the number of barks that dog barks in these 3 minutes. So absolutely, you could have 15 barks. I've had some people question 300 barks, but there are some very barky dogs out there. You could have 300 barks, but you cannot have half of a bark. Even if it's a fast bark or a quiet bark, it's still a bark. So here, that fraction would not make sense as a possible output. The reason this is our warm-up is because our lesson is going to be related to this idea of possible inputs and outputs. The name of this lesson is domain and range. So of course, one of our objectives is to know what is meant by the domain and range of a function. But also, the focus of this lesson is when given a description of a function in a situation, can we determine reasonable domains and ranges for those functions? The focus today is really looking at descriptions and these stories about functions and identifying domain and range. And tomorrow we'll be spending a lot more time with graphs. To start, the first part of this lesson is going to be similar to the warm-up, where on the screen I have a bunch of different numbers, and our job is going to be to decide whether each number is a possible input for the functions that we're looking at. Specifically, we're going to look at 2 different functions. And what I'm going to have you do is pause the video and sort these numbers into 2 groups. List the ones that you feel like are possible inputs, and then a list of the ones that are not possible or impossible inputs. The first story that we're sorting these for is this one here. It is the area of a square in square centimeters is a function of its side length s in centimeters. We also have the equation a of s equals s squared defines this function. I'm going to get you started here because I'm asking you about possible inputs. It's really important that we know what the input is in this situation. Do you know what the input is here? It is going to be the side length of the square. I know that 2 different ways. I know it because, again, here's that phrase, a function of. So I know what comes after it is always our input. And then also, since they gave us an equation, we know when you're looking at function notation, this part here in the parentheses is also always your input. So that lets me know S, which I'm told here is the side length, that is our input. So for this first one, pause the video and looking at all these different values below, make a list of which ones are possible and which ones are impossible for this situation. Come back to the video when you have your answer. So in class, when I do this, we usually start with the ones people are confident are not possible. And usually the first ones I hear are those negative numbers, right? You cannot have a side length where one side of the square is negative. So we can eliminate those two negative answers. I've had some people say that they're very confident you could have a square that has side lengths of whole numbers. Whole numbers are numbers like 9, 15, 72, 4. You could definitely draw a square where you measure one side and it's 9 centimeters. But you could also measure a square and it's not a whole number. So that means that these decimals and fractions are all options as well. This fraction here has confused some people in the past because that numerator is bigger than the denominator. Remember, you could always change that to a decimal if it helps you think about a little more. 25 fourths is the same thing as 6.25, so that could be easier to think about. This 0 here, some people understandably have questions about the 0. Could you have a square where the side length is 0? It sounds silly. Generally, we do consider 0 as a possible input, though, because if I show you this on the screen and ask you, measure this square for me right here, well, there is no square right here. So we could say not having a square is the same thing as the side length being 0. 0 just means there's no square. So that 0, don't be too hard on yourself if you didn't include it or not, because like I said, there is some arguments, but we are going to include it in the situation. So really here, the only things that aren't possible are those negative numbers. Anything that's not a negative number would be a possible input. We've got one other story we're going to look at, and we're going to do the exact same thing. For this one, we've got a tennis camp charges $40 per student for a full day camp. The camp runs only if at least 5 students sign up, and it limits the enrollment to 16 campers a day. The amount of revenue in dollars that a tennis camp collects is a function of the number of students that enroll. I am going to pause there because in class we talk about that word revenue. Revenue is the money you're making. So it's just saying the money they make is a function of the number of students that enroll or go to the camp. And then again, we've got an equation here. The equation R of n equals 40n defines this function. You are doing the same task. In this story, you are trying to identify which inputs are possible and which ones are impossible. Go ahead, pause this video now, try this problem, and then come back to check your answers. All right, I went ahead and started this problem the same way we did the last one by identifying the input. Remember, as soon as you find that phrase is a function of, you know the variable that comes after it is going to be your input. You could also use that equation, but what we're trying to describe is the possible number of students enrolled. If you weren't able to do that on your own, go ahead, pause the video here and see if you can identify now which ones are possible or impossible. But if you have your guesses, I'm going to start the same way we did before with eliminating the ones we know are wrong. And again, when I do this in person, usually students begin by saying, I know you cannot have a negative number of campers. So again, in this story, negative numbers aren't possible. Remember, that's not always going to be true. We've seen lots of stories where you can have negative numbers like temperature or money. Just here, you can't have -3 students enrolled. Along with that, the idea of silly numbers of students, you couldn't have a decimal or a fraction of students. I can't have 3/5 students enrolled. I can't have 6.8 students enrolled. And so that leaves us with 0, 9, 4, 15, and 72, those whole numbers. Lots of times, this is where we might stop and say, yeah, you could have 0 students, you could have 4, 9, 15, 72 students. Those all sound possible. But if you look at the constraints in this story, it says the camp runs only if at least 5 students sign up, which means we couldn't have 0 students or 4 students at the camp because we need at least 5. We need at least 5, which means 5 or more. And it also says they limit the enrollment to 16 campers a day. So that means the maximum is 16. It means we could not have 72 campers. So here there are only 2 possible inputs, 9 students and 15 students. This idea of asking yourself what's possible, what's impossible is related strongly to what we are learning today. We said today's lesson is all about something called domain and range, and we're going to start with domain here. Domain is going to be a description of all the possible input values. I want to point out a difference here between domain and the word input, because we've talked a lot about input. We use the word input to talk about a specific variable in a situation. So for example, above we said the input was the number of students enrolled, or you might use the word input to talk about a specific number. So for example, I'm going to put example here. For example, we said above 9 and 15 are possible inputs. Domain is different. Domain is going to be a description of what types of numbers are okay. So, for example, going back to our 2 stories, in this first one we had looked at with the area of the square, we said the input for this story was the side length of the square in centimeters. The domain is going to be a description of what types of numbers could that be. And so if I go back to the work we did, remember we said all of these numbers circled in green were possible numbers. The only ones we eliminated were those negative numbers. So the domain might sound like all non-negative values. As long as that number is not negative, it is a possible domain. It is a not a possible domain. It is a possible input. It is a possible side length. There's other ways to describe that. So you could say all non-negative values, or you could say any value greater than or equal to, and use that inequality, greater than or equal to 0. If I have something that is greater than or equal to 0, it means it's not negative, and it would be a possible side length. I want to put these right next to each other to emphasize the difference between input and domain, because a lot of times students will mix them up. You are definitely going to see questions that ask you what is the domain, and it would be incorrect to say the domain is the side length. The domain is asking what types of numbers could be our input. So keeping this one in mind, kind of like an example, do you have an idea how we could describe our domain for the second story we looked at? Remember, we said the input here was the number of students that enroll in the tennis camp. What would the domain for this be? Go ahead, pause the video and see if you can come up with a description now. I'm going to come back to the numbers we had circled here and use that to help guide our description of the domain. In the past, I've had some students say, we can describe it the same way. I can say it can't be negative, or I'll say all positive numbers. But the problem with just saying positive numbers is because, look, we've got red X's through a lot of positive numbers. Like these fractions are positive, but we said those aren't okay. That description of your domain has to be as specific as possible. So it's not enough for me just to say positive numbers, because we got rid of some positive numbers like these fractions and decimals, because when you're talking about students, it can't be a fraction or a decimal. So then in the past, I've had some students say, well, maybe whole numbers. It has to be a whole number because whole numbers are positive. They have to be positive. And it means it can't be the fractions or decimals. That's getting closer because you are right. The numbers we circled are whole numbers. But again, that doesn't explain why we eliminated the 4 and the 72. A good description for our domain in this situation is we would accept any whole numbers between 5 to 16. Remember, we eliminated the 4 and the 72 because we said we need at least 5 students to sign up and a maximum of 16 students. So that description of what type of numbers our input could be any whole number between 5 to 16. We're going to continue to practice that description in the second part here. But again, I want to emphasize the difference between input and domain. Input is like the specific variable that you're looking at in the situation, or it can be a specific value. Like we said, 9 could be the input. Domain is we're trying to come up with a description of all the different types of numbers that work. And we want that description to be as specific as possible, like whole numbers between 5 to 16. We're going to continue using these same 2 stories for our second part where we focus in on the outputs. So going back to the story about the area of a square, this time I'm also providing a graph to go with the equation they gave us for that story. So this graph is just showing different side lengths for squares and what the area would be. And using this graph, we're going to come up with 3 possible input-output pairs of this function. So for example, the one I get a lot in class is if the side length is 5, I can use this graph to see that the output would be 25. So 5, 25 is one possible pair of inputs and outputs. I usually see that one first in class because that's the only point that this line directly goes across. But don't forget you have an equation too that can help you. Go ahead, pause this video now and see if you can come up with 2 other ones. All right. Some other ones I hear in class are like 6, just the next one here. 6, it looks like it's just above 35, but we don't have to guess what it is because we've got this function here. This equation says to find the area, you're squaring the sides. So 6 squared is 6 times 6, which is 36. We could do the same thing with 2 maybe. 2 is right here. It looks like it's just below 5, and it is because 2 squared is 4. These are not the only options. I've had students come up with the values for 1, 2, 3, 4, 5, 6, 7, and 8. Remember, there's also decimals in there because you had told me earlier you could have a side length with a decimal. But we've got 3 here just to get us starting to think about the situation. So we're focused in on the outputs. So the outputs are these second numbers here, which represent the area. And if I wanted to describe all of the possible outputs, we are talking about something called range. Range is going to be all of the possible output values for a function. So for example, earlier we described all of the possible input values, the domain, as any number greater than or equal to 0. How would you describe all of the possible output values? I'm going to do the same thing we did earlier. Remember, our output in this situation is going to be the area of the square. So if I wanted to describe all of the possible output values, that is the range. How would you describe the range here? Well, we can describe it the exact same way. Notice, looking at our graph here, that our area, it has to be positive. It's starting here at 0, and we only have those positive numbers. But just like before with the side length, area can be decimals or fractions. It can also be whole numbers. It just can't be negative. So your range we could describe as any number greater than or equal to 0. Or remember the other way we had described it earlier is we said all non-negative values. There are lots of different ways you can describe this. You could even describe it using the inequality sign if you wanted to. You could say that your area has to be greater than or equal to 0, like that. It's just a preference of how you want to do that. Here we had our domain and our range were the same. Both of them we described as any number greater than or equal to 0. Do you think that's always going to be the case, where the domain and the range are the same? Well, thinking about where we started on the warm-up with the barks and the time, notice we weren't okay with the same numbers for that warm-up. I can go all the way back to it. During that warm-up, for when we were talking about the input time, we were okay with the fraction, but something over 180 seconds we weren't okay with. But then our range, our outputs, we weren't okay with fractions in that situation. We were okay with whole numbers. So they might not always be the same. I name that because I want to make sure you're not leaving this video thinking they're always going to be the same, the domain and the range. So we talked about the area. Let's go to the one I really think is fun, which is the one about the tennis camp. I've got the story here if you need that reminder. And to start this one, I've got, similar to the warm-up, asking you questions about two specific numbers and could these be possible outputs. Pause the video to think through this question now and come back to the video when you're ready to get an answer. Just like the other ones, I started by identifying what the output is to help me think about could these be possible outputs. Again, I found that phrase is a function of and use that. I know the variable that comes before that phrase is always our output. So I've got the amount of revenue is our output. So the first question is asking, could 20 be a possible amount of revenue they make? $20 sounds like, yeah, that could be the amount of money you make. But if I go back to the information in the story, or if I look at this equation at where the output would be, both of those are reminding me that you're only getting $40 per student. So how would you make $20? You'd make $20 from half of a student, and that we've already established is not a thing. So 20 is not going to be a possible output. So what about 120 then? 120, well, if now I remember this $40 per student. So $120, that's 40, 80, 120. $120 you could make from 3 students. And I'm going to write that down. $120 is the money they would make from 3 students. Students kind of got cut off, but you know what I'm trying to say. So $120, that's a possibility, right? Wrong, because the same thing we had talked about with domain, we said you need at least 5 students to sign up. So having only 3 students is not a possibility. So here, 120 is also not a possible value for a different reason this time, for the reason that it would mean there's 3 students and we need at least 5. So notice this one here is going to be a little trickier because we really have to think about all of the constraints in the story, that they're making $40 per student. We said that there needs to be at least 5 students. And then remember the other part of the domain, we said we need whole numbers from 5 students up until 16 students. Those were all the possible inputs. There's one other thing I want to look at before we name the range here, and that are 2 graphs that could relate to this. Notice for both graphs, we got number of students on our x-axis and the amount of dollars in revenue on our y-axis. And the question I want you to think through is which graph could represent this function and what's wrong with the other one. If you need to pause this video to think through this question, you can. Definitely, since we had just a moment ago said that 20 is not a possibility and 120 is not a possibility for the amount of dollars that you could earn in this situation, it helps us see that the second graph here, this is the correct one. This graph is really intentional about the values it's trying to communicate. Here, this line is showing any point on the line is a solution to the equation and would be a possible pair of numbers for the story. But we're seeing that's not going to be the case for the same reasons we said a moment ago, like where you can't make $20 and you can't make $120. This second graph here is really intentional about showing 5 students would be $200, 6 students would be $240, and showing all of those possible values and not all the numbers in between them. So this right here is something that could be helpful to think about as we try to describe the range. My range isn't going to be all numbers from 0 to 700 or all positive numbers even, because there's a lot of different dollar amounts that it's not possible for them to earn. And this graph is showing all the exact ones they can earn. So let's get to the point now. Let's describe the range, which is all the possible output values. Our range, we're noticing is real specific numbers. And one option you can do for the range is you can literally list out all of the specific numbers. So I know 5 students could make them $200. 6 students could make them $240, and write all of those different numbers: 200, 240, 280, 320. I'm not going to spend all this video writing them down. The very last one would be 16 students. 16 times 40. I do not know that. 640. So all of those 200, 240, 280, 320, all the way up to 640. You could list all of those numbers out. However, that takes a lot of time. And like I had to do up here, it takes some multiplication too. And so there is an easier way. One thing you notice as you're listing all these numbers up is each time you're adding $40. And so we can describe our range as multiples of 40. It looks like there's a negative sign there, but that's not what I was trying to do. Multiples of 40. Multiples of 40 meaning the numbers you get when you count by 40. So 40, 80, 120, 160, 200, 240. But notice those first couple multiples of 40 I listed, we didn't want. You told me earlier like 120 was not okay. So we want specifically the multiples of 40. And then I'm going to write between. The smallest one was 200. And I'm just going to make a little note for us. 200 is the revenue for 5 students. So multiples of 40 between 200 to 640. 640 is the maximum revenue if the maximum number of students came, 16 students. And so you could describe your range that way instead. I think this situation here is one of the most complicated ones we have to do for domain and range, where you're talking about very specific numbers and trying to find the language to describe those. And a lot of times it comes down to this first part, the multiples. When you're looking at a specific situation where you're making $40 and not $40 an hour, $40 per student, and you only want those specific numbers mentioned for your range. To practice everything we've learned here in this lesson, I have a cool down problem for you all to try. Pause the video here, read through the story. For me, it's very similar to the tennis camp one we did together. In this one, there are questions about possible input and output values, as well as having you describe the domain and range. Try this problem for sure, because it's a great way for you to check in and see how well you're doing on today's topic. And come back to the video when you're ready for an answer. I went ahead and started this problem the same way I would suggest you start any problem, no matter what it's asking, is identify your input and your output. If it's got that phrase is a function of, it makes it real easy. I know what comes before it, the total dollar amount earned, that's going to be our output. And then what comes after that phrase, the number of members who perform community service, that's going to be our input. I'm also going to go ahead and circle any relevant information to those. So our output, the dollar amount earned, it's helpful to know that for each student who does community service, they're earning $5. That's related to the dollar amount they're earning. And then if I need to think about the number of members who are performing community service, it's going to be helpful for me to know that there are 12 students in that club who could do community service. So the first two are similar to the warm-up we had done with the dog barking over time. It's just asking, could these specific numbers be possible inputs and outputs? So for the first one, is 5 a possible input value? Input, remember, is the number of members who performs community service. So is 5 possible? Absolutely. I know it's possible because there are 12 students in the club. So you could have 5 students could volunteer. It might be good to start thinking about here. 5 is a possibility. Can you think of some numbers that wouldn't be possibilities? That might help you up for numbers 3 and 4. For number 2 is 24 a possible output. I'm going to match that to output in green. So I'm thinking about the dollar amount earned. So is 24 a possible amount of money they could earn? $24 sounds like a possibility, but if I'm thinking about that information I have circled here, they're earning $5 for each student. So there's no way for them to earn 24. So no, my reason could be $5 per student means you can't make $24. Oops, $24. You could make 5, 10, 15, 20, 25, but not 24. So here's the main part of this lesson. This right here is really the big goal for us, is to describe domain and to describe range. So for domain, I'm thinking, what are all of the possible numbers we could have for our input? Input is the number of members. So for domain, if I think about possible numbers of students who could volunteer, I know I can't have negative numbers because I can't have -3 students, -2 students. Can I have half a student or 6.8 students? No. So that means it has to be a whole number. So now I know when I describe it, I'm not going to say any number. I'm going to have to say whole numbers. Am I okay with all whole numbers? I could have 0 students volunteer. That would be sad. 1 student, 2 students, 3 students, 4 students. Is there any number I'm not okay with? Could I have 100 students? No, because I know there are 12 students in the club. So I'll say whole numbers. You can write it as a range from 0 to 12. You could say whole numbers up to 12, anything like that. For range, I'm going to do it similarly. So my range, I'm matching to my output, which is the dollar amount earned. With money, I know money can be negative. It can have decimals, but we talked about it earlier here. The idea here is to focus on the $5 per student. So I couldn't make like $2.50 because it's just $5 for every student. So for my range, it's going to have to be multiples of 5 because we're making $5 per student. Now, to figure out my range there, I can use my domain to help me out. So multiples of 5 from, well, the smallest number of students who could volunteer is 0. And if 0 students volunteer, it means $0. So I'm starting at 0, and I'm going to go 5, 10, 15, 20, 25. Where am I stopping? Well, the most students I could have volunteer is all of them, all 12 students. And if 12 students volunteer, 12 students times $5 each gets me to 60. So I'm going to say multiples of 5 from 0 to 60. Now you could list them all out, right? 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. It's a lot of writing. And it is just easier and more clearly communicated to say specifically we're focused on multiples of 5 from here to here. Hopefully you found this video helpful. Understanding domain and range in part 1 of this lesson is really important for what we're going to be doing tomorrow in part 2, where we focus in on some graphs. Thanks so much for watching. Have a great day.